Hi class, welcome to Scholar Dog. Welcome back to chemistry. This session we are going to continue our focus on math and we will specifically do density. I am your teacher, Meg Gifford. So density is a mass over a volume. The unit is typically in grams per milliliter. Now note, since we're learning conversions as well, when they say per, you can rewrite that as an equivalence. 1 gram or X grams equals 1 milliliter. So a per means equals 1. The other thing to note is that 1 milliliter is the same thing as 1 cubic centimeter. So you can exchange these. And in healthcare, they say 1 cc, which means a cubic centimeter, but it would be the same thing as milliliter. So if you have 1,000 milliliters, you also have 1,000 cubic centimeters or 1,000 cc. These are all interchangeable. In order to find the density of an unknown object, we are going to be using Archimedes' principle. So Archimedes' principle has a formal definition. A body immersed in a fluid is subject to an upward buoyant force equal to the weight of the displaced fluid. For us to be able to use it, we need to put this in simple terms. You can tell from this picture that Archimedes was doing this a while back. So volume displacement of water will give us the volume of an object. What that means is if we put an object into water and we can measure a final and an initial, we can subtract the two and get the volume of the object. We use graduated cylinders in chemistry because they give us precise measurements. So here is my lump of gold. And if I take a cylinder that has enough water in it to completely submerge the gold, I can read an initial, I can read a final, and if I subtract the two, I can get the volume. Now recall that when we read an initial, we have to read the tick marks. So this is reading 10, 11, 12, 13, 14, 15, 16, 17. Because it's going to the ones, we can write it to the tens place. And I saw 17.1 for my initial. Once I put the gold in, the upward buoyant force pushes the water up and it gives me the volume of the gold by displacement. So my new volume is 15, 16, 17, 18, 19. It's a little over 19. I said 19.8 milliliters. Now remember, I could also call it a cubic centimeter. Same thing. And we tend to use cubic centimeter more often when we're doing a solid. The mass, 51.842. We typically use a balance to measure the mass. And then also recall, because you couldn't see it as well on that slide, that there is a dip in water based on the attraction to the surface. If we read the lowest point of the dip, that's called the meniscus. We need to be eye level with that. We need a balance so that we can get the mass. And it says density often has units of grams per cubic centimeter. We know that we could also say grams per milliliter. Again, whenever they do a backslash, we can write that as an equals. So we could say milliliter and cubic centimeter are the same, so we can write it like this. Usually when I'm doing math conversions, I immediately take things like density and I write it like this so I can see it as a conversion unit. So remember that grams is a mass. You have to categorize and organize your units. Remember that cubic centimeters or milliliters, same, they are a volume. So let's say that we collect a boulder and take it back to the lab where you weigh it and find its mass is 100 grams. Now, we did kind of poor man significant figures here because you're not really supposed to put a dot, but I wanted to mark 3 sig figs to make it clear. You then determine that the volume is 40, and there's a dot right here. We aren't technically supposed to be doing this when we're charting good data because it is so easy to miss just one dot. But the question is, we have 3 sig figs with a dot, 2 sig figs with a dot. It's good to mark them. Where SF is sig figs, SF is sig figs. We have our mass. We have our volume. And we could call it a milliliter or a cubic centimeter. I'm going to drive home, those are interchangeable. When we divide this out, 100 divided by 40 to 2 sig figs, we get 2.5 grams per cubic centimeter. Remember, this is just a conversion if we want to use it. We can write it like this. And density is a very useful conversion unit. You need to know the density of water. So it's 1 gram per milliliter. Remember, again, conversion factor, we can write it as 1 gram equals 1 milliliter. We could write it as 1 gram equals 1 cubic centimeter. Again, conversion units do not limit to your significant figures. They are infinite with significant figures, but it is a conversion factor. So let's try density as a conversion factor. Gold has a density of 19.1. It's pretty heavy, pretty dense. If you have 600 grams of molten gold, how many milliliters? So you need to put in your given. Start with the given. Write your density as a conversion. So immediately we took this out. 19.1 grams per milliliter, and we are going to write it as 19.1 grams equals 1 milliliter. And when I put this here, I should always put the unit so I can make sure that they cancel out on the diagonal. Whatever unit I have left on top will be my final unit. I started with 4 significant figures. We consider most conversion units infinite. So I ended with milliliters, my final unit, and 4 significant figures. You have to know prefixes for conversions, and you have to memorize these. So there's not a lot that you have to memorize in chemistry, but prefixes are one. And it's good to know that a mega is a million. They use a big M. A kilo is 1,000, it's a little k. Deci starts to be less than 1. So if you have a meter stick, it's about, if you hold your hands out wide, you have your meter stick. If you break it into 10 pieces, you have a decimeter. If you break it into 100 pieces, it'd be about the size of a dime, you have a centimeter. If you break it into 1,000 pieces, so it's 1/1000th, it's about the size of a gnat, you have a millimeter. If you broke that meter stick into 1,000,000 pieces, you would need a biology microscope to see each piece and put it back together. But it would be 1/1,000,000th, and a micro has a funny little symbol, a mu. A nano is 10 to the negative 9th, or 1/1,000,000,000th. And then pico goes even smaller, 10 to the negative 12th. Notice when we're doing the units, it's always 1 mega would equal 10 to the 6th of your base unit. 1 kilo would equal 10 to the 3rd of your base unit. So if you had a gram, 1 kilogram would equal 10 to the 3rd grams. If you had 1 deciliter, it would equal to 10 to the negative 2nd liter. So when I say base unit, that means no prefix in front. If you have 1 milliliter, that means 10 to the negative third liter. If you have 1 microsecond, that means 10 to the negative 6 seconds. So again, all of the pairings that go here with these numbers would be your unit with no prefix, and then you would write a 1 next to the prefix. Here is a classic medication example. Medication often it comes with a density for that medication. A medication has a density on the label of 1.50 milligrams per milliliter. Remember, that's equal to 1 milliliter. So we could rewrite it right away. Like this. And the doctor orders 500 grams. The doctor was precise to give us 4 sig figs. How many liters do we give the patient? So our goal is to convert 500 grams to liters. Start with what you're given, your 500 grams. Make sure that the next unit you have on the bottom, so it cancels out, is gram. And here we're using the prefixes. 1 gram is 1,000 milligrams. Since we have milligrams here, we can use our density here. So we just took this and used it down here. We put the milligrams on the bottom so they'd cancel out, and we got milliliters. And again, we're using a prefix system. We're going from milliliters to liter. There's 1,000 milliliters in a liter. And our final unit is right there. And we end up with 4 significant figures. So in 2 places, we did prefix conversions. These are very, very common. There's always 2 ways to write them. You want to know both ways, and you have to memorize your prefix relationships. Thank you for joining this session of Scholar Dog Chemistry. I hope to see you in the next session.